This is the end of the Chapter 6 review. I think it's the harder problems, and most everything in this review is going to make it onto the test. So even though they're a little bit harder, you can't skimp and cheat on them and skip them, otherwise you won't do so well on the test. Both problems 23 and 24 are exponential equations. Exponential because the letter is in the exponent, equation because there's an equal sign. And one way to solve exponential equations is rewriting both sides with the same base. For these problems, it wouldn't really be possible to do. 12 is not a power of 3, so it's not going to be practical to solve that problem like we did earlier in the review. What we're going to do for the problems 23 and 24 is we're going to introduce logarithms so that we can get the exponent out of the x out of the exponent. So for 23 and 24, I'll start off by taking the log of both sides, and then I'll rewrite the side that has the exponent so that the exponent is a coefficient of the logarithm. So my first step, I took the logarithm of both sides. My second step, I used the exponent to multiplication rule, made the exponent a coefficient of the logarithm, and now I can divide both sides by the log of 3, and that's going to isolate the x. The reason I'm dividing by the log of 3 is because this means x times the log of 3, and to get rid of a multiplication, you divide. A non-rounded answer, a non-decimal answer, would be just to say x equals the log of 12 over the log of 3. The instructions say give me a 2 decimal answer, so I'm going to break out my calculator. And on my calculator, I'm going to do log of 12 divided by log of 3. My calculator is very particular about parentheses, and if I don't enter it actually forces the parentheses on me. At least it forces the left one on me, and if I don't close the left parentheses, then it's going to yell at me. So my calculator gives me 2.2618595. And it says to round to 2 decimals. The number in the second decimal place is a 6. When you round to 2 decimals, you're either going to leave that 6 a 6 or bump it up to a 7. You look at the number after the 6 because it's a 1. You're not going to round that 6 up to a 7. You're going to leave it a 6. And so for my answer, I'm going to say x is approximately 2.26. If I want to check, it's completely optional. But if I want to check, I should probably use the decimal that's not rounded so much to get a better checking. So the original problem is 3 to the x equal to 12. The more decimals in my answer that I put in for x, the more accurate my checking is going to be. I think if I plug that in for x as opposed to the rounded version, then I'm going to get either an exact checking or a checking that's super close. So I just simply change the x to the non-rounded answer, and my calculator tells me that the left side simplifies to 12, and that's what I need to be, because for an answer to be correct, you should be able to plug it back into the original problem and have both sides come out to the same number. 24 I always put on the test. 24 is way harder than 23, and it's probably worth the same amount of points, and it's among the most missed problems on the test. So just like I did 23, I'm going to introduce a logarithm on both sides of the equal sign, and that will allow me to make the exponents free, the x's free of the exponents. When there's an exponent, you don't generally put an exponent in a parentheses. The exponent kind of works like a parentheses. On the right-hand side, when I go to rewrite it, I have to think of the exponent as it was in a parentheses. So after I take the logarithm of both sides, just like I did for 23, I'm going to take the exponents and drag them out in front of the logarithms. So I get x times the log of 2 equals, in a parentheses, x plus 4 times the log of 5. So now I have 2 x's and no exponents, meaning I shouldn't get the problem set equal to 0, but I need to get the x's on the same side of the equation. And before I can do that, I need to clear the parentheses that I put in on the right-hand side. And that's a real easy parentheses to clear. I'm going to multiply the x by the log of 5 and just write that as x log of 5. And I'll multiply the positive 4 times the log of 5, and I'm going to write that as plus 4 log of 5. To get the x's to be on the same side of the equation, I'm going to multiply x minus, I'm going to subtract x log of 5 from both sides. When I do that, on the left-hand side, I have an x log of 2 minus an x log of 5. And on the right-hand side, I cancel out the x log of 5, and I'm left with a 4 log of 5. Now on the left side, I'm going to treat the x as a common factor and do a 1 parentheses greatest common factor factoring. So I'm going to factor out a common factor of an x on the left-hand side. Forgot to write the 2 here. And what you're going to be left with is the log of 2, which is that 2 that I forgot to write, minus the log of 5. On the right-hand side, I'm just going to leave that for this step, 4 log of 5. It's going to make my calculator work a lot easier if I condense these two logs into one, so I'm going to do that. If you have two logarithms written with the same base separated by a subtraction, you can make those two logarithms into one logarithm using the minus to divide rule. And that's what I just did there. I took the two logarithms that were base 10, rewrote them as one logarithm by dividing their arguments because there's a subtraction between the arguments, between the logarithms. Now I'm going to divide both sides by the log of 2/5. I snuck that 2/5 in a parentheses because I know my calculator is going to require that parentheses. So technically, I get x equal to 4 log of 5 over the log of 2/5. This is actually an exact answer. The instructions say give me a 2 decimal rounded answer. And so I'm going to use out my calculator. And on my calculator, to get the 2 decimal answer, I'm going to go 4. I don't know if I need to hit the times. I don't think I will. I'll go 4 log of 5. And then for the fraction, I'm going to hit my divide key, and it'll show a slash. And then the log of 2 divided by 5. I'm going to hit the divide key to get that. And then I'll just round it. So 4 log of 5 divided by log of 2 divided by 5. My calculator gives me negative 7.0258883189. I'm rounding to 2 decimals, which means that number 2 is either going to stay a 2 or it's going to round up to a 3. I look at the number after it. Because it's a 5, I'm going to round it up to a 3. And for a 2 decimal answer, I'm going to say my answer is x is approximately negative 7.03. I should check, and didn't leave myself a lot of room to check, but I'm going to sneak it in right up top. So to check, I should take my answer and plug it in for x, and the more decimals I carry in my answer, the better my checking is going to be. And in this case, I have to check on both sides because there's an x on either side of the equal sign. So for the left side, I need to enter that. So I'm going to go 2 up arrow negative 7.0258883189. This is probably going to give me something in scientific notation, but it didn't. So this gives me this number. On the right-hand side, I need to do something similar. Go 5 to the negative 7.0258883189 plus 4 power. And I'm going to do that on my calculator by going 5 up arrow. And I'm going to put a parentheses in for that operation, negative 7.0258883189 plus 4. When I hit enter, if I get this number that's right above there, then my answer is correct. And I get exactly, if you look at that number and that number, they're exactly the same. I don't need to write them down. It takes too long to write them down, and it's not really necessary. But this was my checking without actually writing down so much. You can do the entire checking without writing anything down. You can do it all on your calculator if you don't want to write those decimals down. But you should check these problems because any problem that has an equal sign, you should get a numerical answer for x, and it should be checkable. 25 through 30 start off with logarithms, and we're going to rewrite the problems without logarithms. These are logarithmic equations. The word logarithmic means somewheres in the problem there's going to be a log. Equation, there means there's going to be an equal sign. Some of these problems will get decimal answers, but I almost think none of them. Maybe one of them will have a decimal answer. So in order to do problem 25, I need to scratch out the log and create an exponential equation. And that's what I'm going to do for most of these problems between 25 and 30. So I'm going to scratch out the log and create an exponential equation. An exponential equation has an equal sign and there's a letter in the exponent. So I'm going to cross out the log, and the 3 and the equal sign kind of stay right where they were. The 3 is going to stay on the left-hand side of the equation. The equal sign is going to stay in its position. The x is going to get free of the logarithm and move to the right-hand side of the equation, where it's just going to be by itself. The 4 is going to move to the left-hand side of the equation because I'm creating an exponential equation and the 3 is the base. The 4 has to be the exponent. I can use my calculator if I can't do this in my head, but I know that 3 to the 4th is 81. And for an answer, it's enough to write 81 equal to x. I should check it because it's very easy to check. So to check it, the original problem was the log base 3 of x equals to 4. I'm going to change the x to 81, and then I'm going to break out my calculator and do log of 81 divided by log of 3 to simplify the left-hand side. So log of 81 divided by log of 3. It needs to say 4 because the right-hand side is already 4. And because it says 4, I know my answer is correct. I think problem 30, if you don't check, you'll run into some problems. The algebra will produce 2 solutions and only one of the 2 actually checks. 26 is the one where I'm going to give a 2 decimal answer. So on 26, I want to do the same thing. I want to write the problem as an exponential equation without a logarithm. Unfortunately, I can't see the base because I have the shorthand ln written in the problem. So on the first step in problem 26, I need to replace ln with log base e. They're equal to each other. Ln is shorthand of log base e. Now I can cross out the log and create an exponential equation. So to the left of the equal sign, I'm going to cross out the log. The base is going to stay. The equal sign is going to stay. The 2 is going to move to the left-hand side and become an exponent. The x is going to move to the right-hand side and become, I guess, the answer. So this is technically the answer. And this is probably a better answer than a 2 decimal version, but I'm going to get a 2 decimal version just because the instructions ask for it. So I'm going to go second in ln and type e squared, and my calculator gives me 7.389056099. The number in the second decimal place is an 8. Either I leave it at an 8 or round it up to a 9. I look at the number after it, it tells me to round it up, and I would take either of these. This is a non-decimal answer, and it's actually more accurate. And this is the 2 decimal answer. The instructions ask for a 2 decimal answer, so this is probably what you should write. But you certainly, I'd live with an exact answer because in some sense it's better. For checking, I just take this number, plug it into that, and I should get a 2. So on my checking, I won't even write anything down. I'll do it all on my calculator. I'll hit ln, which is from the original problem, and then this number, 7.389056099. When I hit enter, if it gives me 2, I know my answer is right. And because when I hit enter, the left-hand side of my equation is what I figured out, came out to 2. The right side's already 2, so I know my answer is correct. I'll do something similar for 27. I'm going to scratch out the log and create an exponential equation. So for most of the problems between 25 and 30, I'm going to get rid of the logarithm by this strategy. Create an exponential equation. So I scratched out the log, I left the 2 on the left side, left the equal sign where it was at. The 5 is going to move to the left-hand side and become an exponent. The x plus 1 is going to move to the right-hand side. And when I move it to the right-hand side, I don't really need the parentheses because it's just kind of freed up of the logarithm, so the parentheses isn't necessary. I wrote them, but I'm going to drop them immediately. Now I have a simple equation to solve. 2 to the 5th you can do on your calculator if you don't know it. 2 to the 5th is 32. So my answer for problem 27 is going to be 31 equal to x. For checking, I should go the log base 2 of 31 plus 1 equal to 5. That 31 plus 1 is easy enough to add. So I'm going to find if the log base 2 of 32 equals to 5, and I'll use my calculator. And on my calculator, I'm going to do log of 32 divided by log of 2, just rewrite the left-hand side, and it's going to give me the 5 that the right-hand side is because my answer is correct. So log of 32 divided by log of 2 gives me 5 for the left side. The right-hand side's already 5, so I know my answer is correct. So problem 28 is a bit different in that it has 2 logarithms, one on either side of the equation, and this is the only one between 25 and 30 that I'm not going to create an exponential equation. If you looked at problems 27, 26, and 25, on the right-hand side there wasn't a logarithm, and it made sense to write an equation with an exponent for those. But on problems 28, I can just drop the logarithms because they're set up to do that. When you have just one logarithm on either side of the equation and the bases are the same, you can solve the problem by just dropping the logarithms. So I drop the logarithms, I have a nice linear equation, which means I shouldn't set it equal to 0 and solve by factoring. I should get the x's on one side, the numbers on the other. I'm going to get the x's on one side by minusing x from both sides. On the left side, when I go 2x minus x, I think of it as 2x minus 1x, and I get x. On the right-hand side, when I subtract x, the x's cancel. So this will give me x minus 8 equals to 2. And then I'm going to add 8 to both sides. And this is going to give me x equal to 10 for an answer. This is a really unfortunate answer because when I go to check it, I'm going to get nasty decimals if I break out my calculator, which I'm going to. So for checking, I should go to the left-hand side and do the log of 2 times 10 minus 8, and go to the right-hand side and get the log of 10 plus 2. On my calculator, I could enter just this, or I could simplify it a little bit. 2 times 10 is 20, and 20 minus 8 is 12. I could enter the log of 12 for the left-hand side on my calculator, and on my right-hand side, I can also enter the log of 12. Clearly, these are going to be the same. I don't really need to know the decimal version of a log of 12, but to do the decimal version of log of 12, I would just hit the logarithm button and type 12. Because the base is 10, I can do that directly on my calculator. Both sides are going to come out to this 1.079 number, so I know my answer is correct because I've gotten it to a point here where I didn't need my calculator, but if I entered these on my calculator separately without simplifying, they both would give me this 1.079 number that has a lot more decimals. 29 is tricky because it has 2 logarithms, but they're on the same side of the equation, and it has a number to the right of the equal sign that doesn't have a logarithm. Ultimately, I'm going to solve this like 25, 26, and 27, meaning ultimately I'm going to scratch out the logarithm and create an exponential equation. For problem 29, it has 2 logarithms on the same side of the equation that I need to condense to one logarithm. And in problem 29, because there's a minus between the 2 logarithms, when I go to condense the left-hand side from 2 logarithms into 1 logarithm, I'm going to use the minus to divide rule. It basically says if you have 2 logarithms with the same base separated by the minus sign, that you can rewrite those 2 logarithms as 1 logarithm if you divide the arguments. Now I have a more complicated version of like problems like 25, 26, and 27. So I can create an exponential equation by scratching out the logarithm. I'm going to leave the 2 on the left-hand side. The equal sign's going to stay between them. The 1's going to move to the left-hand side and become an exponent. The fraction's going to move to a right-hand side. And the fraction I didn't put in a parentheses because I knew it wasn't going to need a parentheses. Alright, so now I need to do this problem, solve this problem. It's a little bit tougher. I have a fraction with, and that just makes it harder. So the left-hand side, that 2 to the first power is just equal to 2. These types of problems I like to solve by cross-multiplying. So I'm going to rewrite the left-hand side in its fraction form, because 2 can be written as a fraction if you just write it as 2 over 1. So I made the 2 logarithms into 1. I created an exponential equation, and now I'm setting it up to solve by cross-multiplying. So I'm going to cross-multiply down, and I'm going to cross-multiply up. Cross-multiplying down, I get 2 times x plus 6. Cross-multiplying up, I get 1 times x plus 14. This is going to give me 2x plus 12 equals 1x plus 14 when I clear the parentheses. I'm going to minus 1x from both sides, and I'm going to minus 12 from both sides. What that's going to do on the left side is going to give me an x, because 2x minus 1x is x. It's going to cancel the 12s. On the right-hand side, it's going to cancel the 1x's, and 14 minus 12 is 2. I claim that this is my answer. Anytime I solve an equation, I can check, and I probably should check. So the checking for problem 29, I should go and see if the log base 2 of 2 plus 14 minus the log base 2 of 2 plus 6 equals to 1. And I'm going to think of this as the log base 2 of 16 minus the log base 2 of 8 and see if that equals to 1. And on my calculator for this left-hand side, I'm going to do, for the first logarithm, log of 16 divided by log of 2. And then I bring the minus sign into the problem. And then for this next log, I'm going to do the log of 8 divided by the log of 2. So if I enter that, that's entering the entire left-hand side. That's going to simplify the left-hand side down to a single number. It better be 1 because the right-hand side's already 1. So on my calculator, log of 16, close out the parentheses, divided by log of 2 for that logarithm, then this minus sign, and then the log of 8 divided by the log of 2 for that logarithm. That's the entire left-hand side. When I hit enter, it's going to simplify the entire left-hand side. Because the right-hand side is 1, it better come back with a 1, which it does. So this gives me 1 equal to 1, so I know my answer is perfectly correct. 30 is the tricky problem. 30 is the problem that if you don't check, you might write down an answer that doesn't belong. So just like 29, on the left-hand side, there's 2 logarithms that I need to condense to 1 logarithm. The difference between problems 30 and problem 29 is the sign between the 2 logarithms makes me combine them differently. So step 1 in problem 30, rewrite the left-hand side with 1 logarithm using the plus to times rule. That essentially says if you have 2 logarithms with the same base and they're separated by a plus sign, that you can condense the 2 logarithms into 1 logarithm if you multiply the arguments. Now I'm going to need the FOIL to clean up that logarithm. So I'm going to do firsts, which are x times x, which is going to be an x squared. Outers are x times 6, which I'll write as a plus 6x. Inners are 2 times x, which I'll write as a plus 2x. And last, which are 2 times 6, which I'll write as a plus 12. I'll combine the outers and the inners, and I'll be able to rewrite the left-hand side as a log base 2 of x squared plus 8x plus 12. Now I'm going to scratch out the logarithm and create an exponential equation. The 2's going to stay on the left-hand side. The equal sign's going to stay where it's at. The 5's going to move over to the left-hand side and become an exponent. And the argument's going to move over to the right-hand side. And when I move it over, it's okay to leave it in the parentheses, but the parentheses aren't necessary anymore. The left-hand side I can simplify better. I could do it on my calculator if I didn't know that 2 to the 5th is 32. And on the right-hand side, I don't need those parentheses, so I just dropped them. Because I have an x squared, I need to solve by factoring, and before I can solve by factoring, I need to get the problem set equal to 0. So I'll minus 32 from both sides, and that will give me 0 equals x squared plus 8x minus 20. And I'll factor this. This factors into x plus 10 times x minus 2. Now that I have it factored and set equal to 0, you set each of the factors equal to 0. So you go x plus 10 equal to 0, x minus 2 equal to 0. For the x plus 10 equal to 0, you'll minus 10 from both sides and get x equal to minus 10. For the x plus 2, minus 2, you'll plus 2 from both sides and get x equal to 2. It's going to turn out that if you wrote both of those numbers in your answer, you're going to lose points because only one of them is going to check. The other one's going to be outside the domain of both logarithms, and you'll get an error message. Let me check both of these just to show you that what I wrote for my answer is appropriate. So first I'm going to check the one that works. Usually the positive works and the negative doesn't. To check x equal to 2, I'm going to plug a 2 in for both x's. So I'm going to get the log base 2 of 2 plus 2 plus the log base 2 of 2 plus 6, and that's supposed to equal 5 because the right-hand side is 5. Before I use my calculator, I'm going to rewrite this as a log base 2 of 4 plus the log base 2 of 8, and that's supposed to equal to 5. And to do this on my calculator, I'm going to go log of 4 divided by log of 2 plus log of 8 divided by log of 2, and that's going to simplify this left-hand side to the number 5 if my answer is correct. So on my calculator now, log of 4 divided by log of 2 plus log of 8 divided by log of 2, and it gives me the 5 that the right-hand side already has. So I knew 2 was going to check, and I also know that negative 10 is not going to check. When I go to check x equal to negative 10, I should go, I'll do it up here. I'm going to go log base 2 of negative 10 plus 2 plus log base 2 of negative 10 plus 6 equal to 5. That's going to give me the log base 2 of negative 8 plus the log base 2 of negative 4 equal to 5. Logarithms with negative numbers give you i's, just like the square root of negative numbers give you i's. The left-hand side is going to have an I, the right-hand side doesn't have an I, so it's not going to check. My calculator doesn't really know how to do logarithms with negative numbers, so it's going to give me an error message. On my calculator, to handle the left-hand side, I'll have to do log of negative 8 divided by log of 2 plus log of negative 4 divided by log of 2, and my calculator is going to come back with like a non-real answer error message because the left-hand side has an I, and my calculator doesn't know how to do logarithms of negative numbers, and so it just says, hey, I can't do this. And because the left-hand side simplifies to have an I, and the right-hand side has a 5 without an I, you know these don't check. This is left-hand side is something with an I, a non-real imaginary answer. The right-hand side doesn't have that. So negative 10 doesn't belong in my answer. When I wrote my answer down, I only wrote the answer that checked. All right, 2 problems left, both word problems. One easy-ish word problem and one hardish word problem. Problem 31, I call it a one-step problem. Problem 32 is going to be a two-step problem. Both problems give me a formula. In problem 31, It's talking about money, and the money formula that we're going to use is A equal to P e to the RT, where A is the future amount of money, P is the starting amount of money, R is the interest rate as a decimal, so if it's a percent I need to make it into a decimal, and the T is the time in years. As I go through this problem, the words or the numbers are going to give me amounts for 3 of the 4 letters, and I need to solve for the unknown. So as I read through this problem, how long will it take an initial investment of $2,000 to triple? $2,000 is the initial amount of money, so it's the starting amount of money. I want to triple $2,000 in the future. I'm going to multiply 2,000 by 3 and get 6,000 for the future amount of money. So how long will it take an initial investment of 2,000, starting amount of money, triple future amount of money, if it's expected to earn 3% as a decimal, 0.003 interest compounded continuously. So the T is the unknown because it's asking me to solve for how long. It wants to know how many years. I'm going to round to 1 decimal. So I'm going to plug these numbers into the formula. I'm going to go 6,000 equals 2,000 times e to the 0.03 for r times t. To solve this, first I'm going to divide both sides by 2,000. That's going to give me 3 equals e to the 0.03t. And then when we did the video over this, I took the natural log of both sides because it made the calculator work a little bit easier. So I'm going to take the natural log of both sides. The left-hand side I'm going to leave written as the natural log of 3. The right-hand side I'm going to write 0.03t times the natural log of e. The natural log of e is equal to 1, because if I hit the natural log button and then second and divide for the e, you can see that the natural log of e is 1. So this is really 0.03t times 1. So I can think of the right-hand side as just 0.03t. So this now is just the natural log of 3 equals 0.03t. I'm going to divide both sides by 0.03. And then I'm going to use my calculator. And on my calculator, to do that left-hand side, I just have to go the natural log of 3. The 3 needs to be in a parentheses. And then just divide it by 0.03. So natural log of 3 divided by 0.03. That gives me an answer, and I'm supposed to round to 1 decimal. So I'm just going to write 36.6 because the number after the 6 tells me not to round it up. So for my answer, because this is a number of years, I'm going to say it's 36.6 years. I was asked to round to 1 decimal, and I should probably put words with my answer. I'm finding out how many years it takes the $2,000 to grow to $6,000, so I tacked on the word years. So 31's the easier of the word problems. 32 takes multiple steps to do because you're not given kind of the growth rate or the interest rate. So in problem 32, it's this population of a city problem. And I have to do this problem in pieces. So I'm going to look at the first 2 sentences. So the population of a city is expected to double in 40 years. The city currently has 10,000 residents. What I'm going to do with those 2 sentences is I'm going to use those 2 sentences in conjunction with that formula that we'll talk about to get a value for, in this case, k, which is equivalent to the r, the growth rate. So this formula right here that we're going to use, the p of t is the future population. The p sub 0 is the starting population, just like the future amount of money and the starting amount of money. In this case, we're talking about people, so it's populations. The K, instead of being an interest rate, it's the growth rate. And the T is the number of years. So what I'm going to do is use the first two sentences to get a value for K, then I'm going to round to 3 decimals. So in for the future population, in for the current population, I'm going to plug in 10,000. In for the future population, I'm going to double that 10,000 and make 20,000. And in for the number of years, I'm going to plug 40. So from those sentences, I can get a value for K by just shoving the numbers into the formula. So I'm going to get 20,000 for the future population, which is the left-hand side of the equal sign, equals the starting population, 10,000, times e to the K times 40. Do the same algebra that we did for the last problem, meaning I'm going to divide both sides by 10,000. And that's going to give me 2 equals, and I'm going to rewrite that exponent as 40k. So I get 2 equals e to the 40k. I'm going to take the natural log of both sides, which will allow me to rewrite the left-hand side as 40k times the natural log of e. And because the natural log of e is equal to 1, this is really 40k times 1. So I can rewrite this as natural log of 2 equals to 40k, because 40k times 1 is just 40k. I'm going to divide both sides by 40, and this is going to give me a value for k. And I'm going to round to 3 decimals. So whatever my calculator comes out with here when I go the natural log of 2 over 40, I'm going to use for k for the next step of the problem. So natural log of 2 divided by 40. The number in the third decimal place is a 7. I'm either going to leave it a 7 or round it to an 8. If the number after the 7 was 5 or bigger, I'd round it up. Since it's not, I'm going to leave it at a 7. So I'm going to leave my k as 0.017. Now I'm going to move on to use the second and the third sentences together to answer my question. So keep in mind that the k that I just figured out equals 0.017. And now I'm going to use this. The city currently has 10,000 residents. 10,000 residents. How long will it take to get to 50,000? I'm using the same formula. The P of t is the starting number of people. I'm sorry, the P of t is the future amount of people. The P sub 0 is the starting amount. The K is the growth rate as a decimal, and the T is the number of years. So as I read through what I have written down here, city currently has 10,000 people. That's the starting number of people. How long will it take to get to 50,000? 50,000 is the future amount of people. And I figured out the K from the last step of the problem using the first 2 sentences. I'm going to plug those numbers into the formula, and I'll be able to answer the question, how long will it take? And it's going to be in years again. So I'm going to put 50,000 into the left-hand side of the equation for the P of t. I'm going to put 10,000 into the right-hand side of the equation for the P sub 0, and then I have an E, and then in for the K I'm going to put 0.017, and I'm going to leave the T a T. Now I'm going to solve this equation using the same strategy that I solved for the last couple problems. So I'm going to start off by dividing both sides by 10,000. That's going to give me 5 equals e to the 0.017t. I'm going to take the natural log of both sides. The left-hand side is going to become the natural log of 5. The right-hand side I'm going to rewrite as 0.017t times the natural log of e. The natural log of e is equal to 1, so I can just drop it and get the natural log of 5 equals 0.017t. And then I'm going to divide both sides by 0.017. And on my calculator, I'm going to do, for the left-hand side, the natural log of 5 divided by 0.017. And I get 94.6728. 94.672818 years. And I don't know what rounding I need to do. So it says round your final answer to 2 decimals. I rounded the k to 3 decimals, but my final answer gets rounded to 2 decimals. My final answer is the number of years. This is the number of years, and I want 2 decimals. So I'm just going to write 94.67 years for my answers. I could write a sentence saying it will take 94.67 years for the population to grow to 50,000, but I'll live with just the word years because that's what I would just instinctively write. All right, so that's the entire review. The test is going to be long because the review was long and the chapter was long. It's a 150-point test, so if you can get to class early, I always can let you start about 15 minutes early, so it could really help if you get to class early if you're a slow test taker.